Warm greetings to you all, dear children. Today we'll be discussing the continuation of the heat and temperature themes. First, we will see in detail about the different types of thermometers. First thermometer is maximum and minimum. This thermometer is specially designed to record the maximum and minimum temperature of an area during 24 hours of the day. We would have heard on radio or watched in TV news the reporting of maximum and minimum temperatures of major cities. The daily newspapers also give the temperature readings of our town. How many of you would like to see the weather forecast regularly? Yes, mostly a lot of people skip that. But we are really eager to see the weather forecast in a rainy season. Are I students right? Yes. Next, we see digital thermometer. They regarded as the fastest and most accurate type of thermometer. There is much doubt about the use of mercury in thermometers because mercury is a poisonous material and when a thermometer breaks, it is impossible to dispose of it. And we are using optical thermometer today that does not contain mercury. After the corona, we now use the optical pyrometer in several areas. It is a non-contact temperature measuring tool of type as it measures temperature by determining the light intensity of a specific wavelength produced by a hot body. The third one is a thermometer in the laboratory. This thermometer measures other objects such as boiling water and ice temperature and is commonly used in the laboratory. It is much longer than the surgical thermometer and the glass tube does not have a kink. It is commonly calibrated between minus 10 degrees Celsius to 110 degrees Celsius. Next, I will display a short video about digital thermometer and thermometer in the laboratory. Keep tuned. Mercury is used in clinical thermometer, but mercury is a toxic substance and is very difficult to dispose of. For this reason, digital thermometers are widely used nowadays. A digital thermometer does not contain mercury. It has a plastic body which is easy to use. It consists of a thermistor which is used to sense the temperature. Another small device present in this thermometer that measure the current passing through the thermistor and sends information to an LCD, that is liquid crystal display, where the temperature is displayed in numerical value. So it is easier to read the temperature since the temperature is displayed in numerical value. Next, we are going to see laboratory thermometer.
This thermometer is most commonly used in labs to measure temperature with a high degree precision. The range of a laboratory thermometer is generally from minus 10 degrees to 110 degrees Celsius. It consists of a sealed glass tube enclosing a fine uniform bore capillary tube. The bulb and a part of the stem are filled with either mercury or red liquid alcohol. To determine the temperature of a liquid, you have to dip the thermometer in the liquid, ensuring that it doesn't touch the walls and bottom of the container. Once the mercury in the tube expands and rises on the capillary tube, you can record its temperature.
Next, what are the precautions to be observed while using a laboratory thermometer? I'll explain the precautionary approaches one by one. Number 1. The laboratory thermometer should be kept upright and not tilt. Number 2. The bulb should not touch the surface of the container. Number 3. The bulb should be surrounded by the substance from all the sides. Thermal equilibrium means the state when two or more bodies are at the same temperature and the exchange of heat between them is zero. Next, we will talk about thermal equilibrium with one small video.
Temperature. Transfer of heat takes place when two bodies, one hotter and other colder, come in thermal contact with each other. This process continues till both the bodies have the same degree of hotness or coldness. At this point, we say that the bodies are in thermal equilibrium state. In the state of thermal equilibrium, a body neither receives nor emits heat energy. Example 1. When no transfer of heat takes place between you and the surrounding atmosphere, your body is said to be in thermal equilibrium state with the surrounding atmosphere. Example 2. Similarly, a furniture in a room exists in a thermal equilibrium with the air in the room. Here the air and the furniture in the room are in same temperature. Here, we are going to discuss heat. Generally, when we stand near fire, the heat of fire enters into our body, we feel hot. In the same way, when we hold the ice piece in our hand, the heat is transferred from our body to the piece of ice and we feel cold. Hence, we can conclude that heat is a form of energy in transit. It is always transferred from an object at a higher temperature to an object at a lower temperature. Definition. Heat is a form of energy which makes an object appear hot or cold. Take two empty cups or vessels or mugs. Fill them with hot and cold water respectively. Now take a laboratory thermometer. Observe the initial level of mercury in the thermometer. Note down the reading in your notebook. Place the thermometer in hot water. Observe the change in the mercury level. Note down the readings in your notebook. Now keep the thermometer in cold water. Observe the change in the mercury level. Note down the readings in your book. We observe that mercury level rises in thermometer when kept in hot water. This implies that heat was transferred from hotter body, hot water, to colder body, mercury in thermometer. Similarly, in the case of cold water, we observe that mercury level comes down from its previous level. The reason is that here the transfer of heat takes place from mercury, hotter body, to water, colder body. From the above activity, we learned that heat is a form of energy in transit. It always transferred from a body with higher temperature to a body with a lower temperature. The steadiness of the mercury column of the thermometer indicates that the flow of heat between the thermometer liquid, mercury, and water has stopped. That is, thermal equilibrium state has been attained by the water and thermometer liquid.
Finally, we will discuss the differences between clinical and laboratory thermometers. Clinical thermometer. It is smaller in size. The range of temperature allowed to be measured by using this thermometer is 35 degrees Celsius to 42 degrees Celsius. There is a constriction which does not allow mercury column to fall on its own. We need to give few jerks for the mercury to make it fall for the next use. Laboratory thermometer. It is larger in size. The range of temperature allowed to be measured by using this thermometer is generally minus 10 degrees Celsius to 110 degrees Celsius. There is no such constriction, so the mercury level falls as soon as it is taken out of the substance whose temperature is to be measured. The mercury level falls to the room temperature on its own. Dear students, try to answer these questions. Copy down these two questions neatly in your fair notebook. Today's homework. Learn and write the following questions in your science rough notebook and get signed from your parents and send a photo to my personal number. Thank you, children.